Okay, so continue our discussion talking about asymptotes? Yes. Talk about that later. Okay? But yes. We don't meet tomorrow. Do we? No. Not if this is first hour. We'll worry about it later, okay? Okay. So, again, talking about asymptotes. Remember, there are two types of asymptotes we're going to be concerned with right now. What are the two types? Yeah, I have vertical asymptotes and horizontal asymptotes. I'll just abbreviate that as VA and HA. How do we find the vertical asymptote? Yeah, very good. So we'll set the reduced denominator equal to 0 and solve. Now finding the horizontal asymptote can be a little bit trickier, at least algebraically. In this case, we have three cases, where the degree of the numerator is greater than the degree of the denominator. There's no horizontal asymptote. This was your slant asymptote situation, but we don't care about those right now. We have the situation where the degree of the numerator equals the degree of the denominator. In that case, we have a horizontal asymptote, and it is y equals the leading coefficient of the numerator over the leading coefficient of the denominator. LC, I've just abbreviated leading coefficient. And the last situation we have where the degree of the denominator is less than the degree, or I'm sorry, the degree of the numerator is less than the degree of the denominator. And in this case, our horizontal asymptote is always at 0. Do you guys remember what we mean by degree? Largest exponent in that polynomial. Yes. And this is all good. What's the alternative that I could do to this, though? The alternate is that we could use our calculator to do this kind of thing. So let's look at an example to just kind of illustrate what I mean by that. do this both ways. We'll do this first using our rules that I just discussed. And then the second way, I'll use my calculator to kind of arrive at the same information. Okay with that plan? So first things first, we'll find the vertical asymptote. So Hallie said to find the vertical asymptote, I need to set the reduced denominator equal to 0 and solve. So let's worry about the reducing part first. What do I need to do to be able to reduce an equation like this? I need to factor the numerator and denominator and see if there's anything that I can cross out, right? So how do I factor something like x squared plus 2x minus 3? It's me looking at the denominator. How do I factor a quadratic like that? Great. So we need to find two numbers that multiply to give me negative 3 and add to give me positive 2. Does anybody recognize two numbers that satisfy that? 3 and negative 1. Does everybody agree with that? So I can factor the denominator as x plus 3 times x minus 1. We spent a lot of time last year in Algebra 3-4 factoring things that look like this. Expectation for this course is you're still able to factor these sorts of things effectively, at least situations where the leading coefficient is 1. Okay? Everybody feels like that's reasonable and they still remember how to do that. If not, speak now and we'll do some more review or practice on it. Okay, everybody sounds like they're comfortable. Let's look now at factoring the numerator. So again, we'll try to do it the same way. We're going to look for two numbers that multiply to give me negative 3 and add to give me positive 3. Does anybody see the two numbers? You're having trouble finding the two numbers, right? What do you think? There aren't two numbers that satisfy that, so the numerator is not factorable. So there's no factoring we can do in the numerator. And since we can't factor the numerator anymore, what can we say about reducing this? That's the point, right? We were factoring this in order to try to do any reducing. Can we reduce this if we couldn't factor the numerator? No. So it's already reduced. Okay? Everybody happy with that? So to solve this then, we can just set the denominator equal to 0. And how do I solve something like x plus 3 times x minus 1 equal to 0? Does anybody remember how we solve something like this? Sophia? Perfect. Yeah. So we can take each piece and set them equal to 0. This is called the zero product property. We're only allowed to do this, though, when I have two things that are multiplied together equaling 0. If that was equal to 1, I cannot do what we just did there. If there's an addition sign between them, cannot do what we just did there. Must be multiplication between the two things. And they must equal 0. Everybody's okay with that? All right. So to solve, I get negative 3 and positive 1. when I subtract 3 from both sides and add 1 to both sides. So I have 2 vertical asymptotes at -3 and +1. Is everybody happy with that? Feel like you could do that again? Shouldn't be too bad. For the horizontal asymptote, what do I need to consider for the horizontal asymptote? We need to look at the degrees for the numerator and denominator. What is the degree in the numerator? 2. What is the degree in the denominator? 2. So we have the situation where the degree of the numerator equals the degree of the denominator. And our rule states then that to find the horizontal asymptote, what do I need to look at? The leading coefficient of the numerator, which is 1, over the leading coefficient of the denominator, which is 1. 1 over 1 is 1. Are we happy with that? Let's look at what this, or how we would do this sort of thing using our calculator. Okay? So I'm going to clear this out of here. Does anybody remember how I put a fraction into my calculator? Alpha y equals. Yep. Good. And then the option we like is the first one, numerator over denominator. And do x squared plus 3x minus 3. And then x squared plus 2x minus 3. And then I'm going to graph this just in my standard window, so I'll do zoom standard. So if I go and look, let's actually do this. It's a little bit easier to see now, huh? How fancy was that, guys? Pretty cool. All right. So if I look, it looks like I have a vertical asymptote right about here. Everybody agree with that? If I look at my x-axis, that's -1, -2, looks like -3 to me. Agreed? If I go over here, oops, and I do the same thing, looks like I have a second vertical asymptote. You agree with that? That appears to be at +1. And that supports what we saw earlier. if I look at, for a horizontal asymptote, I see one here that looks like it's at about +1. Everybody agree with that? Now, on your test, I would ask you to justify that horizontal asymptote using an XY table. So what I mean by that is I'm just going to use my calculator and show you that for very large x's, the y value is about 1. And for very small x's, the y value is also about 1. So I'm going to go and press second and the window button. And I'll start my table at, I don't know, like 1,000. And I'll go up by, say, 1,000. I'm sorry, start at -1,000 and go up by 1,000. So that's going to be the very far left end of my graph. And I'm going to look for my y-coordinates being about 1, but never always on one side of 1. So like 0.9s or like 1.0s, 1s, you know, everything either up on top of 1 or below 1. Everybody's okay with that idea? So I'm going to press second and the graph button. That'll open up my table. So if I look at -1,000, I'm at 0.99, -2,000, 0.995, -3,000, and now we're giving me fractions. Bugger. Oh, I forgot about that. Okay. So if I don't want the fraction in my table, I need to type this thing in as not a fraction. So I'll just put a parenthesis around the entire numerator. What was that middle number? +3. Minus +2. If I go back to my table now, notice that everything it's giving me is a decimal now instead of a fraction. That's the one drawback of using that fraction command, is when you go look at the table, the responses it's going to give you are going to be fractions rather than decimals, which is kind of inconvenient, but yes. I just picked I picked a very small value and then picked, you know, because I only am concerned with like the very left end of the graph. You should be big, or I'm sorry, very small in this case. But if you had picked like -10,000 to start with, that's fine. Or if you picked -500 to start with, that's probably fine. If you pick -5, not really appropriate. Just needs to be, you know, like reasonably big. And when I say big, I really mean small. Like -1,000 is a small number. So that's us checking the left end. So if you copied this table in, I would consider that reasonable justification. And then to check the other end, I'm going to do the same thing. So I'm going to press second and window to go to the table set. And this time, we're going to start it at, say, +1,000. And see what we see. So second and graph. And you'll see that, as again, everything is on the other side of the number 1. And if you copy this table down, I would consider that those two tables appropriate justification for that horizontal asymptote. So if you forget the rule on how to find those horizontal asymptotes, copying those two tables in to justify the horizontal asymptote was at 1, I would consider perfectly fine. Okay with that? Is that okay with that? Yeah. I didn't say Matt. I said that. Eventually I figured out that's why you got such a strong response from my question, is you thought I said your name. Is that everyone's okay with what I'm saying there, though? So I'm just trying to provide you another way in case you forget the rules on how to find those things. Certainly you can look at your picture and kind of on your calculator and tell where the horizontal asymptote is. And I'm telling you that if you copied these tables in, I would count that for a justification. Kendall.
Would it be the same process with the degrees? Is that like the same?
So the calculator-wise, yes. So say we just had, instead here I had x minus 3 in the numerator. So here the horizontal asymptote should be at 0. And just to kind of confirm that, if I do the same thing, what are these numbers very, very close to? 0, right? Because these are scientific notation with the negative, right? So this is like 3 zeros and then a 1. I'm just 2 zeros and a 1, excuse me. But they're, this stuff is all very close to 0. Does that make sense? And you'd have to check the other end still at negative 1,000, but, you're welcome. So this was the last topic that I wanted to cover from Chapter 1 before we talk about having the test. So let's do the asymptote questions here right now in class from the homework. So those are 23 and 24, if you're following along at home. So we'll take a minute here right now. Just try to do these in your notebook or whatever, and then we'll go through them together in just a bit. Okay, so we'll take, 5 minutes or so. It doesn't take too long to do these. Correct, yeah, we're just finding the VA and HA. Good question, Matt. You'd need instructions there, for sure. So, depending on the way you find your horizontal asymptote, you could supply a table as your work, or you could state the rule that you use to find it. Either is appropriate. All right. So everybody had a chance to do what they can do here? So for 23, what did we find for the vertical asymptote? Good. X equals 1. And you should write x equals in front of the verticals. And what did we find for the horizontal asymptote? Okay, horizontal should be y equals, and then the 1. So the vertical asymptote, we just said x minus 1 equal to 0 and solve. There's no factoring to do in this problem. Everything was kind of in reduced form already, so there wasn't much to do at the front end of that. And then the horizontal asymptote, you could notice that these are both degree 1 polynomials. So it's leading coefficient over leading coefficient. Or you could have graphed this on your calculator and used your XY tables to justify the horizontal asymptote being 1, as we showed in the the previous example. Everybody's okay with that idea? Okay. For 24, I didn't label this. What did you guys find for the vertical asymptote? Yeah, there's 2 here. There's -3 and +3. So hopefully you guys remembered how to factor something like x squared minus 3. Remember that this was that special factoring pattern of a difference of 2 squares. That we can factor a squared minus b squared as a minus b times a plus b. And when you set each of those equal to 0, you get +3 and -3 respectively, right? The horizontal asymptote here you found was y equals 0. You could have done this from the rule, noting that we have a degree 1 polynomial over a degree 2 polynomial. Or you could have looked at the graph on your calculator and used the table to justify that as x gets very big or very small, the y values go to 0. Is everybody okay doing that? Okay, very good. So what I'm going to ask for you guys to do for next time is I have a review. That I'm going to post to PowerSchool, but we're going to start that right now. When we meet next time, I'll take questions from the review. I'll probably end up starting new material after that, and we'll take the test in the following class period. So not the next time we meet, but the time after that. I'd have to look at my calendar to figure out what day that is, but I'll put it on the calendar today, the due date for that. But that's the plan. Does that seem reasonable? And I'll post the key with this as when I post it, just so as you're working on things, you can check your work. So again, when I post this, you can do this work on a separate sheet of paper is fine. You can print this thing out and do it on the pages, that's fine, whatever kind of works best for you. But since I'm posting this along with the key, there's no, I'm not going to check this, but you definitely want to do it in preparation for the test. So let's look at question 1. So this comes from section 1. It just asks, do the following relations represent functions? And then it asks for some justification for that. So if I look at the graph for part A, does that graph represent a function? No, why not? Great. So you could say it fails the vertical line test, and I would ask that when you say that, you draw in an example of a vertical line that gives you that information. And that's enough justification for me. Is everybody happy with part A? If I look at part B, does this mapping diagram represent a function? Yes. Good. That's correct. What explanation would I give? Each of the x's has exactly one y. So notice 1 goes to only one place, 2 goes only one place, 4 goes to only one place, 6 goes to only one place. That's a perfectly reasonable explanation. Everybody's happy with that? If I look at C, does this represent a function? Yes. What explanation might you give? You could say it passes a vertical line test, in which case you can, draw in a couple of vertical lines to show that you kind of checked several places. Everybody happy with that? Okay. How about D? What should I do with D? Okay, so Lexi says let's get the y by itself. And then what would you do with it after you've gotten the y by itself? You could graph it on your calculator and look at the picture. Very good. So if I do that, I will subtract 5 to the other side. And then divide by 3. If I do that, the graph that I'm going to look like, or get, looks something kind of like this. I'm going to skip typing it into my calculator. But the point of the matter is, if you look at this graph, you would say this is a function because it passes a vertical line test. Now, as far as showing your work, I would need to see all of that on the test. So for tomorrow, work on this review, We'll take some questions from that and then probably start the next materials.